So, my name is Ganesh. I started my career in Hewlett Packard's C++ compiler team, worked there for 5 years, represented HP in its for C++ standardization efforts for language and the library evolution. Then I worked in Siemens Corporate Research and Technology for 7 years, worked in the area of software architecture and development. So, written a few books, so I'm talking about that as well in this talk. So, you'll have a question in mind. What are we talking about, right? The key message for this session is architecture refactoring enables business success. Architecture refactoring is the key enabler for business success. That is the key message I want to drive, at the end of this session. So let's, so you'll be immediately curious about this. So what is this thing called architecture refactoring, right? How many of you heard this term before, architecture refactoring? Some of you? Okay, great. So if it can actually accelerate business success, we'll be naturally interested in that, right? In architecture refactoring. So we are going to discuss about architecture smells and how architecture refactoring can be done for refactoring those smells for business success. That's the key idea behind this session. So everyone knows Flipkart here, right?
Yeah,
and
yeah, kind of.
Yeah. And we also know about the Big Billion Day. And what happened?
Started prodding actually.
Yeah, so it got a new name. So if you look at it, is it a technical problem that Flipkart faced, or is it a business problem? Is it a technical problem, right? So basically, the essence of what has happened is there was a sale day, a big day, everybody logged in, and the servers crashed. The people are unhappy, right? Is it something that an architect would expect?
Yes.
Right? And is it a technically solvable problem? Of course, yes, right? So what was not done is architecture refactoring. An exact opposite example of how, if you don't do architecture refactoring, it will cripple your business. And look at the positive side of it. If you do architecture refactoring, it will, propel the success of the business, right? It's a very simple idea, right? Now, as we can go along, you will see that it becomes more technical, but the essence is very important. So why are we doing this? That is very important, right? Why are we listening to this session at all? Especially when we are waiting for the beer.
The question there is did their stress testing, did their numbers go wrong there? That's why they failed, or it was because of the architecture problem?
That I don't know. That we don't know, right? Because we are not from. I'm not from Flipkart,
Yeah.
so I don't know what happened. But if you look at from a high-level perspective, what was there was a business situation, a business situation, and the challenge was a technical challenge. It is something entirely foreseeable and entirely addressable, right? When it is not done, it became a problem.
What we thought was they want to do the load test.
using customers and testers.
So very difficult.
Good, but it's also not good to get this name, right?
I mean, what I read was the engineers actually said to the management that it might not be able to handle load above this, so it might be careful about too much publication or something. But the PMs and everything they decided to go ahead with it.
Yeah. Okay.
Yeah. So it was a number issue.
Yeah. So actually, Ravikant, who is this? Who gave this quote? This is my manager in Siemens. He made a very nice statement. I would always remember in my life. He made a very interesting statement. The best way to understand a system is to look at it when it fails. I mean, if you look at all of you are architects here or have exposure to architecture. Don't you appreciate this beautiful statement? How many times we think, oh wow, it's a beautiful design, beautiful implementation, everything is working great, and it fails. And now you drill deeper and all the loopholes come out in the picture. Oh, this is not working, that we didn't think about it. Getting an idea? So So this is also very key for software architecture and for refactoring. So smells could be translated into the flaws in architecture, and refactoring is all about addressing those flaws, right? So this is the essence of what we are going to talk about. So one way to understand, especially living with legacy systems. Many of us live with legacy systems, right? In fact, somebody has said that after the first day, the system anyway becomes legacy. You start making your own code, right? Though it is in development, right? So continuous change is the only way to live with any real world software, right? So one way to look at is actually cities as an analogy. So actually, this analogy was very interesting. Actually, I came through this analogy through our own book. Grady Booch, when he wrote forward for our book, he gave an interesting statement, right? Cities, like software, continuously undergoes change, and it needs to be adapted, just like cities. And we all live in Bangalore, and we know how much true it is, right? So what we have is something called enormous infrastructure debt. Do you agree? But what we don't usually think is that our software also has huge debt. Do you agree? Whatever the project you're working, I don't know what project you're working on, but do you agree that your project has huge debt? I mean, so many things need to be done, so much needs to be done, and it slows down the project, right? It gets us into trouble, right? Unless we do continuous refactoring, we end up like Bangalore, which you don't want, right? So what is technical debt? Technical debt is something, something that accrues as you keep on taking shortcuts. What is the solution to the Bangalore's problem? If you ask our traffic police, make one ways. That's a shortcut, is it not? It's not a solution to the problem. It's just putting a band-aid and say that your cancer is gone. So architecture debt. See, technical debt is a wide thing. Like when you are working in your software, it's painful, right? So that what you have is a debt, and there are various dimensions to this debt. You have architecture dimension to it, you have test dimension to it. One of you were mentioning, right? So like if you need to have 85% of your code covered by unit tests or functional tests. What if you don't have? We get into test debt.
Just to clarify, you should have 100%. 85% is just our
okay.
number that we want.
Okay, I'll put it this way. If you have 10% unit test coverage and functional test coverage, you have testing. But is it enough? Of course not, right? So what you get is something called test debt. And you have similarly code debt, you have design debt, and you have architecture debt. So what we're talking about is the architecture component of technical debt, which is called architecture debt. So how do you quantify architecture debt? Architecture smells. How do you address architecture debt? Architecture refactoring. Getting a big picture, right? So I just wanted to give you the big picture, which before actually going into the details about the smells and refactoring, right? So think about refactoring as refactoring a city, right? So you have a crazy signal here just outside our this building, right? And what could be refactoring there? Putting an underpass or a flyover, right? So what is interesting is there are other meanings of refactoring as well. For example, metro. It's another road. So what we have is a refactoring of a city, right? This is evidently refactoring, is it not? What is also very interesting is we don't realize yet another way of refactoring, which is very important. And this, I am sure, as architects, almost every one of us miss out. You know what it is? This is also refactoring. What is this? In a city, for example, let us say you want to come up with a dedicated path for cyclists. Can you do it in Bangalore? Yes. Theoretically, yes, practically no. Right? It is so crowded. You don't have any space, right? But this is a way of architecture refactoring. Coming up with metro is obviously refactoring, but coming up with a cross-cutting solution is also architecture refactoring. I will touch upon this very, very important topic, how as architects we miss out this very key point about cross-cutting concerns. So what are cross-cutting concerns in software architecture? Think about it. Very hard to answer, is it not? Right?
You're providing an extra feature here.
Extra
So
feature.
what would be a refactoring?
I'll come to that. Can you just hold on for a minute? I'll come to that point about how. Yes, of course, it could be a feature as well, but it's about cross-cutting concern. Like for example, security. I'll come to that. Right? Please hold on to that.
I think here refactoring would mean that provide a simpler set of interfaces which can be used. The underlying code remains the same, but the interface is different now. So you have now easier.
What you're saying is correct, but there's a different connotation when it comes to cross-cutting concern architecture. I'll come to that. Please hold on for that. So why do you do architecture refactoring? What are some of the key concepts, right? So one is when your future velocity goes down. What is this crazy thing called future velocity, right? It's very simple, right? So let us say we have n number of features, and over a period of time we have releases. So in the first release, I had some 100 features, just like that. Just to just a vague number or general number. So next release you had 80 features, and the next release you are able to put only 40 features. In other words, the number of features what I could implement in the software is going down throughout the releases. What does it mean? Something is pulling us back as a team. Do you appreciate that? Does it happen in our software? All the time, is it not? Right? So this is called reducing, the future velocity getting reduced. Right? So then you have the problem of reducing the cost. Cost is a major concern, right?
The features are going down, it's a good sign. Features are getting completed.
No. See, what I mean by future velocity going down is, the customer wants more and more features, but as a team, you're not able to support features. Why would that happen? Because architecture is crazy. The software is creaking. We're not able to add it anymore. Like we all want more vehicles to go in our roads, but we're not able to do that, right? That is reducing the velocity, right? And all the projects want to reduce their costs. Agreed? And there is also concept of architecture decay. You come up with a beautiful architecture, and over the period, it gets outdated, right? Or it erodes, and that's architecture decay. And then you have the problem of modernize. I have my beautiful application working in mainframes, but I want to move to microservices. I want to move to cloud. I want to put it in my mobile. Can I do that? Yeah, maybe give me 10 years. But 10 years, it will have something completely else, right? So, there is always need to modernize. That's actually a burning need. And, there could be new business needs that could come up on the way. And one of the very important things is, addressing NFRs. Scalability, for example. How do I scale? Right? So just be not adding more machines. It doesn't make any sense to keep adding machines, right? So how do I refactor the architecture to support scalability, performance, reliability, etc.? So these are some of the reasons why you may want to do architecture refactoring. So just a quick recap. So you may want to do architecture refactoring to actually speed up the feature velocity. Like, your software project is like, making your bullet cart run. Go, right? It's not designed for speed. The poor cows, right? Or bulls, whatever. So, whereas you have your F1 car, is it designed for speed? Yes. So, this transformation is not possible in the physical world, it is entirely possible in the cyber world. So when you do that, it becomes architecture refactoring.
You have to be careful with that example. F1 cars won't run on Indian roads.
Speed breakers.
Yeah. So any guess who this person is? He's Bertrand Meyer, a creator of many languages like Eiffel. So he made a very beautiful statement. Bubbles don't crash. What do you mean by that? So, like when you come up with architecture, what do? Put lots of boxes, arrows, bubbles, right? Looks great, but have you lived through that? When I created my first system, it was 9 years back exactly. I was like a proud person. I have done so much good programming work. Let me design. I got an opportunity. Let me create my first system, and put lots of diagrams. This box will do this. This box will do this. This where data will be stored. This how it will be processed. Latest technology. All this. When implementation happened, it goes to the customer. The poor thing is not able to even get up and running, right? All my ego was shattered. I was like, what? I got a beautiful design. Nobody told me about this. these are the problems that could happen in the architecture. Have you had the experience? Right? So this boxes and the bubbles looks great till it comes to implementation, right? That's when we get real problems and we realize. So especially NFRs, crashing, for example, is a reliability problem. It's not able to support 1,000 customers, 2,000 customers, right? When it was supposed to support million customers, okay? So this happens. So how do you support these NFRs, right? So architecture refactoring is the key way. Reduce costs, for example, number of installations of Oracle, right? So often the cost is calculated for databases on number of instances that you have. If I can reduce the number of instances, I could save lots of money, or I can move from proprietary to open source or free software, and that could save me money. And that will require architectural changes. It's not like just taking software from my Microsoft Windows platform to put it in Linux. Yeah, get it working. It doesn't work that way, right? So that will require refactoring, right? And architecture decay, as we discussed, and modernize. What do you mean by that? Move to cloud, move to things like, for example, mobiles, etc., and make it more profitable, right? So this is the overall why we care about software architecture refactoring, right? Now, of course, you want more details. This is very just very high level overview. Don't worry, we'll come to that. So the first question is, what is architecture refactoring, right? We give all the reasons for doing architecture refactoring, but still I haven't answered the question, what is architecture refactoring? Tell me, right? So is it code refactoring? You have some runtime checks, and if you have a base type C, then you don't need this. You can just say C dot get margin. So this is an example of code refactoring where I am actually simplifying the conditions, right? So as you can see, the impact is very localized. And when you say refactoring, typically we mean code refactoring. Agreed? Agreed? Yes. This is what we mean by code refactoring. So basically, it's actually preserving the behavior. The external behavior doesn't get affected. Will external behavior get affected by this? Of course not, right? Is it refactoring? Is it useful? It's of course useful, right? Now, in our earlier work, we realized that refactoring is much more than code refactoring. So we worked on something called design refactoring. What do you mean by that? You look at software as different level of granularity. You have something like code, you have some classes, and you have subsystems. Now, your concern is very localized to code level. That becomes code smells and code refactoring. You have a large method chains, right? Switch statements. All these are very localized concerns, is it not? Right? Fowler beautifully classified these, smells, and he also listed refactorings. But what we realized was, this is good, but we need design level as well. So, for example, let's say I have cyclic dependency, and we can actually refactor to avoid cyclic dependency, right? So this work emerged out of this, and this is the book that came out last November, released worldwide, with forewords by Grady Butch and Stefan Dakasi, right? And I have quiz questions at the end of this presentation. You can get this book, okay? Now that's actually the world work. So when we were working on this topic, we realized that many of the smells what we are discussing are actually architecture smells. For example, this is a specific example what we were faced with. So when I was looking at some cyclic dependencies like this, what I realized was, when I looked at further deeper, I realized that the cycles go much beyond classes. We had cycle dependencies between packages, right? So, example, you can see this. I mean, the diagram is not very clear, but what I am saying is you have two packages or n packages, and they have dependency on each other, right? So that becomes cyclically depending in packages, which is an architecture smell. So that's a new set of smells, and when I looked at the literature, there are only few smells documented. So what do you mean by architecture smells? Let me give a simple example, right? Let us say I have a dependency on a jar or a DLL or a library, right? And that's unnecessary dependency. Assume that that's not necessary. But I have so much space in my PC, I can easily deploy it, so it's not a problem. Let us say I just move that software to mobile. Now, does it become a problem? It does become a problem, right? So I have a dependent jar, and when I put it in my mobile, it occupies more space. And mobiles, if you want to install a new game, if it is 1 GB, you will really like it? No. So you will say, no, I don't want this. right? So suddenly this becomes a problem, and that's what is called as a smell. And this is not at the level of code. Are you talking about long method here? Are you talking about large classes here? What we're talking about are in the levels of dependencies. We're talking about subsystems, right? So this becomes a more bigger concern. So now as an architect, you have to carefully look at it. Is this library really required or not? Can I replace with another library which is very small if it is not necessary, or if it is necessary, right? So this is what is called architecture smells. So if you look at these terms, it won't make much meaning to you, but I can go through these details to explain it, and I will give some examples. Okay. So just before we go further for specific smells and refactorings through case studies, I'll just summarize by saying that code refactoring is an entirely different ball game compared to architecture refactoring. Right? For example, as a developer, I can just do code refactoring. But if you want to do architecture refactoring, for example, if you want to remove a dependency, that requires a much wider knowledge. Right? Those static analysis tools are statically, if I analyze the dependencies, the dependency may not be shown, but it may be using through reflection, for example. In that case, if I remove the dependency, the compilation will work fine. Sometimes testing will also go fine. When you put it in the customer machine, it will crash there. Right? So you need to have a bigger picture of your software to understand what is going on, right? So that's why you need architects or a team to actually do architecture refactoring. Just to give an example of what's the difference between code refactoring and architecture refactoring. These are two different beasts. It's like one poor cockroach versus one dinosaur. Okay? They're different beasts, so we should be very careful about architecture refactoring. If we're talking about difficult stuff, I'll give some specific examples. You will realize what I'm talking about. No, not really. So design refactoring is about, I would put it in the level of, to easy to understand, it's about classes. So if you are talking about very low level things, for example, within the methods or within a class, it will become code refactoring. I mean, the concern is very, very localized. Whereas classes, it's a little bit more within a subsystem. Whereas architecture refactoring is across subsystem. Basically, you're talking about the whole software, and what it is doing. So, it's much more risky, but much more beneficial as well, when you do it properly. Did I answer your question?
Design refactoring, will it impact the change?
Sometimes it can. Sometimes it can impact.
Then will not become an architecture.
No, it's about the extent of change what you're doing. So can I take you through some case studies that will become very clear to you? Huh? Yeah. A very, very valid question. I'll go through that. So what I'm going to do is, not going to talk theory. I'm going to give very practical examples from my own experience or what is documented in books and literature to take you through some specific examples of smells and how they have been refactored. Right? Yeah.
You can answer this later also. When we say smell, architecture is smell, yeah, especially mobile and example what we do.
Yeah.
From my view, it won't be a smell. It's basically the system was not meant to be to deploy for mobile, yeah. So
Of course, yeah.
The smell is somewhere. I don't know whether it will be
That's a beautiful question. Thanks, Sanjay. So it's all about context. What was not a problem before becomes a problem now, right? So smell is a very general term. So for example, smell is something that screams for refactoring. In this case, does it scream for refactoring? Then it's a smell, So I mean, it's more theoretical definition for me to discuss what is smell, what is not a smell, what is this refactoring, what is that refactoring, etc. What I am interested is how can I benefit, how can I use it in my projects, right? That's what we are going to discuss. We're going to cover specific case studies, 5 case studies on architecture smells and refactoring, right? Before that, I want to tell what is architecture. That's what the key for this presentation. Architecture is all about the principal design decisions you make for a system. What is the loop index I use? Integer I equal to 0, I is less than 10, I plus plus. Does it affect the whole software? Doesn't. I am going to use map reduce approach for solving this problem. Is it an architectural problem? Architectural decision? It is, right? Because it's a major decision, it's a significant decision. Tomorrow, I cannot change it very easily, right? So that becomes an architecture decision. So when we view software architecture in terms of the principal decisions that we make when creating the architecture, It's a very, very powerful approach. And we are going to use that approach for looking at smells and refactoring. So what are the dimensions of these architecture decisions? Right? So when it covers NFRs, I can decide, for example, I have a security layer in my banking application. Every call has to go through that security layer. Is it an architecture decision? It is. It's a major decision made about NFRs. It could be constraints. I could say that I am using this Cassandra library or I am using this Hadoop library because my licensing terms allows that. Is it okay? It's an architecture decision. Can I easily change the database later? It depends on the ease of change. So it could be an architecture decision, right? Or it could be about the technology what you're using. Let's say I decide to use Java, and 1 year later I say, I don't like Java, let's move to C#. Can I make that? So in other words, I have made a decision. So what is very interesting about all this is, it completely changes your perspective to architecture. Do you agree? It is not about boxes and arrows and how they're related anymore. It's about the fundamental decisions that you make about a system. And you have cross-cutting concerns. We'll discuss more about this later, okay? So this is a specific case study. Case study 1. This is a banking application where the architect had made a decision that every call has to go through a security layer. Why? Once a user is authorized and authenticated, what do you mean by authentication? You have rights, privileges, right? A normal user like me would have a different privilege compared to an administrator. And if all the calls don't go through that layer, somebody else can say that I am an administrator, and what will happen? Right? You got the idea? So the architect, when designing the system, said that we have a security layer. All the calls have to go to the security layer, right? And there are some people who have joined later in the team, and the architecture was busy with other projects. And what happened? Some bug fixes came, and they added some code, and unintentionally, because lack of awareness of whatever the decision was made, they skipped the call, the layer. And how did came to know about that? The hacking happened, and you do the audit trace, and you realize, oh goodness, the calls have to go through this. The security layer, they're missing. Okay. It happened there, is it?
Yeah, last month.
Oh, okay. Oh, thanks for that. I know about that. So here, what's very surprising is the name of the smell is called skipped layer smell, which doesn't look dangerous at all. Right? Like mosquitoes, doesn't look dangerous at all unless it spreads dengue. Right? So we have something very innocent looking thing called skipped layer, and depending on the context may become a major impact, right? Which could lead to a hack, for example, a security attack, for example. So in this case, what is the refactoring? It's no rocket science. Make sure that the calls go through the layer, right? But getting an idea what smells and refactoring is all about?
So, yeah.
See, I mean, I would hesitate from actually getting into what is the definition of smells, and the fact is that we are doing a fresh research work nobody has explored before. These smells are not documented in any books, in any research papers. So we are going to document it in future. So depends.
Because good architecture should not have allowed it to even happen. So even if a programmer makes a call without the call should have played.
So it depends on how you view. I get your point. It depends on how you view it. For example, if you so it's about the decisions you have made. Where is it we are talking about? Yeah, here. So it is a decision. An architecture decision has been made. See, whatever maybe we don't know the context. The architect made a decision saying that all the calls has to go through the security layer, right? It was not documented. It was not followed later by somebody, and it led to a violation of that, right? So that led to a security attack.
But that's the learning, right? So
That's the learning, yeah.
When you make decisions like this, which are extremely important, especially security, then we also have to make built-in checks, which will make it impossible for anyone to skip this layer.
Excellent. That would be an architecture refactoring, right? we are entering into an unexplored area. We need to understand that, right? We are entering into an area that was not uncovered before. So we are deciding what is architecture smell, what is the definition of that, what is architecture refactoring definition of that. So it's a very different territory altogether. We are not talking about core smells. If somebody talks about refused request, long method chains, it's very well known. What is long method chain? What is the smell? What is refactoring? All well known. But you are entering a new territory, right? I very much agree.
You're saying that you're documenting that what are the steps by
Yeah.
Is that only on theoretical basis you're going to propose it? Documentation or the research is still not that made.
Yeah, that's still open. Yeah.
It, right?
Yeah, it's still
so
open.
are you going to implement that and then document and then provide it for research purpose, or like only a theoretical basis you are doing it?
Right now in a very early stage. So we have just started. See, typically work like this will take 3 or 4 years to mature. So we are in a very early stage. We are just in 6 months.
Implement that, whatever.
Yeah, perhaps.
proposals.
Yeah. So, okay, this is another interesting case study. So, sorry for some of it, maybe a repetition because I've given this presentation in Powerness before. I'm sorry for that. And I hope we can go on till 5:30, right? Anna? Is it okay?
Yes.
Okay, great. So, this is a very interesting case study. So, this happened in one of the projects I was earlier involved with. A very simple question. How much effort does it take to implement a feature to change the color of a button? If I ask you, what will you say? Few minutes? Few days? Right? Month? Weeks? Okay. Years?
What is the size of button?
Okay, so let me give you the context why I'm asking this question. So this happened in a very interesting case study, a real project. So one fine day, a team received a request saying that, there was a customer-facing team which received a request saying that we want to be able to change the color of the button. We don't know why they requested it. They saw this. There you have the requirement engineers, right? So they said, oh, what is this? Changing the color of a button. Let's take it in. And said that, yeah, put it in the next release. So it went to the application team, which was actually responsible for that component in which whatever they requested. They saw that the change of the color was not supported by the underlying platform. So what do you mean by underlying platform? So this software, whatever it happened to follow, implemented using a platform. So you had a platform, right? So there's something called product line architecture. I don't know if you heard about that. So you have a product line and you have a platform and you have applications written on top of that platform. Very trivial example, don't take it literally, is to think of something like a suite. Like for example, think of a MS Office suite. You have different applications like MS Word, MS Excel, etc. Right? Do they have similar look and feel? Do they reuse the components? So what you have is actually an underlying platform which is not visible at all to us. For us, it looks like separate applications. To a similar application, which does in a similar way, right? But what you have is an underlying platform, right? Now, this change of the color was not supported by the platform. Why? Because they had a common standard called common look and feel. In other words, every application in the platform should look in the same way. If you allow to change the color of a button, then the look and feel will get affected. Making sense? So they rejected the request saying that we cannot accept this request because the platform does not support it. The customer was furious. I am the highest paying customer for your product and how dare you say very simple request like changing the button or color of the button, you don't support it, right? Do you have any option? Any questions? So it came to the platform team. The platform team said that, see, we cannot change the fundamental architecture design decisions. Now you get an idea? So fundamental design decision made was common look and feel. If I allow applications to just randomly change the colors, then at the end of few years, you'll have some crazy looking applications. All of them are looking different, right? Now, but they cannot say no to the customer. Can you say? So they said, okay, if you change the color of the button, all your components will get gets changed. And now how much effort it takes? It took more than 1 year to implement this feature. Just a very, very simple example of what an architecture design decision is. Here, what is the design decision? Common look and feel. Doesn't look an architectural aspect, right? But it is a key important architectural aspect because it's a fundamental design decision. And the smell here is actually a violation of the design decision that was made. And the refactoring is to stick to that design decision.
So I have some experience.
Oh, wow, great. Yeah, please share.
The same thing for font.
Uh-huh.
There was one customer, the customer was old, and she was not able to see the fonts and was complaining, I need a bigger font. And then the entire website or the application font was going big. So then we thought of how to solve it. Then what we did, we just include a screen which will increase the size of the font in her monitor. So that fixed the issue. And now everyone is happy. We don't have to do any development. Only we need one glass which is like lens in front of her screen. That's all.
Oh, okay.
So this is something like innovative things we try.
All this happened in real world. I'll give another very interesting example of architecture refactoring. A very unbelievable example. Okay, but it's true. So one of the customer requests was I should be able to have a link to one of the subtopics in the screen. But this was based on one of the single page frameworks, AngularJS or something. I don't remember which one it was. So basically you cannot have links to subparts in the page, in the same web page. But can you say no to the customer? When you change that, your total approach towards architecture changes. You have to change your technology, underlying technology. So you go back and remember what architecture is all about. So you have technology aspect in this. Why? Because the change of the technology is a major, major design decision. It requires lots of change. So a simple example of bookmarking a subpart of the page may require an architecture refactoring. Right? So another example, very interesting case study. So there was a very smart technical person like you. Okay? So he had lots of experience, some 18 years of experience, and he said that, wow, I'm working in a very large company in the world, and I have seen in my past experience that if this thing could be implemented, this could be the next big generation of products. So I can start on my own company. Why should I give it to my existing company? So he started his own company, and of course, when you start a new company, the biggest thing is money, right? You won't have money. So he took lots of freshers, and he said, I will create a beautiful architecture, and I will guide them every day. So he created a very nice architecture for the next generation of products, and every day, 3-4 hours, he'll work with the team of freshers, and he'll have them implement it. Right? So in 2 years, they had a very, very good next generation software, and it came to the market. It was a huge hit. The customers took notice. Wow, this is an amazing product. Let's acquire them. So they acquired this company, and this guy became suddenly a big rich man. Right? But when you get acquired, typically you have to sign saying that I will work for 2 more years, supporting all this product. So he had to continue in the same big company. And the company who acquired this product, of course, wanted to make it productized and go in a big level. They said that, okay, implement these features. Well and good. Now, when you become part of a bigger company, you have something called quality gates. Right? So it went through this quality gates and the upcoming planned release, and they realized that they had some of the tools like BlackTech, and they realized that they have too many violations. What do you mean too many violations? Commercial jars, open source libraries, copy and paste from the stackoverflow.com, cut and paste algorithms from open source software, everything. Will the company allow you to go ahead? They said that you have so many red flags, fix them, and then we will see about the release. So it has to get, so the feature, implementing features, bug fixes, no, put them aside. This is more critical, right? What happened? They had looked at, they had commercial off-the-shelf software. They had to find alternatives. They had to procure licenses or replace them with free alternatives. And it's such an easy thing to do. You have your whole application using some library, and suddenly you move to another library. What will happen? Application gets destabilized, right? How much effort you require? Huge amount of require. Think about your logging framework. How much code you have? Suddenly say, okay, you move to another logging framework. Can you make it overnight? Cut and replace? Find and replace? No, it won't work, right? So this is what happened, and the release got postponed. What was planned for 6 months got postponed by 1.5 years, and by the time they got rid of all these flags, the cost of the product has gone up very high, because they had to procure licenses, they had to make their own libraries or components, and they had to replace things, and by the time it became very unstable. And by the time the competition came up, and the product sank in the market. So, this is not to be shared, okay? But you can trust me that this is a real example. So, a very beautiful example of how architecture, decisions. Here, if you look at it, making a choice of a library, a technology, right? Which one to use? Licensing factors like this, what we discussed in the morning as well as what we covered, they beautifully come up together when you talk about architecture smells. For example, we are planning to call this smell, illegal dependencies. Why illegal dependencies? Because you're not allowed to have those dependencies, right? And what is the refactoring? You have different refactorings depending on the context. You have to look about, make buy decisions, or do you replace with the fast components, licensing terms, etc. So it becomes a big discussion, right? So I'll come to your question, right? What are cross-cutting concerns? What are cross-cutting concerns? So in software design, people have identified few things as key cross-cutting concerns across any product. What are those key cross-cutting concerns? Concurrency. You have to live with concurrency, no matter what type of concurrency it is. We live with concurrency, either known or not known. Right? You may be a single-threaded application, but still you are running on a multi-core, for example. So you have to deal with concurrency. You have to deal with persistence. You have to deal with exception handling. Right? So these things are known as cross-cutting concerns. Security, for example, becomes a cross-cutting concern. Security is a cross-cutting concern. Yes, we can think of security as a feature, right? But to implement security, it's not enough to have one component for security or one layer for security. No, it's not enough. So let's say you have a product where you want to add security. Can you add security? You can add some security features, but security is a concern that has to be implemented, designed from the scratch. A standard example is DOS, Windows. Windows, is it very secure? No, right? And you know why? Windows evolved from DOS, which was meant for single user, and it did not have the key aspects like the authorization or the permissions, etc. And from the beginning, and Windows actually, if you remember Windows 1.0, 2.0, 3.0, etc., that's called operating environment. You have a layer over your DOS, and then it evolved to a bigger product. But by design, Windows was never secure, so you cannot add security. Yes, of course, you have lots of security features in Windows, but by design, take an alternative. Take Unix, for example. By design, it's secure, right? There will be security vulnerabilities, I agree, but by design it is secure, so it's easy to deal with security in that case, right? So you cannot add security as a feature. So I cannot add exception handling as a feature. Can you add? Cannot, right? You can have an exception handling component, but doesn't mean you handle exception handling in only that component. It's a cross-cutting concern. So all this looks theory. Let's go to practical, right? This in the case of an legacy application. One of the projects I was working with, they had a huge code base, 10 million lines of code, and it was written in C++. 85, 86 times they started this, and by 95 they had 10 million lines of code. And if you are from C++ background, you may know that exception handling features were added in only 95, 96 time frame, right? So before that, Visual C++, for example, had a feature called structured exception handling. Right? So you had some keywords like this, underscore underscore try, underscore underscore catch, and if you see that, the code looks quite different. The thing is, it's spread throughout the 10 million lines of code, and the architects had to make a decision. How do I move from this old structured C++ handling to standard exception handling? As you can see, this is a cross-cutting concern, right? And as you can see, this is a principal design decision, right? The earlier principal design decision was to use structured exception handling, and now they are also making another principal design decision about how they are moved from this to that, right? So they made a very pragmatic decision, or so-called pragmatic decision, saying that I will live with structured exception handling for the old components, and I will use standard exception handling for new components. Great, right? very practical. Till things broke. Till things broke. Few years down the line, 5 years down the line, there are so many bug reports about exception handling problems. What was that? When the exception gets handled within that component itself, let's say legacy component, structured C++ exception handling, is structured in the same component, it works fine. Standard C++ exception handling, you have an exception, you handle it there itself, works fine. When an exception gets thrown from structured exception handling, crosses to standard exception handling component, no defined way to handle it. So when developers had to deal with it, they had their own way of doing it. Somebody did conversion, somebody created a new exception from old exception, etc. And this became, a big problem, right? So, this is an example of architecture refactoring, of why we should be very careful about dealing with these kinds of problems in the real world. This don't happen. Do you live with legacy code? Do you have legacy code? Do you have problems like this?
Sure.
Right? So it helps us think in that direction. How do I deal with existing problems? Sometimes the design decision you make, architecture decision you make, may look very fine in paper. But when it comes to implementation, when you actually realize it, that experience shows that you could actually make a wrong decision. Right? A very good example is this. This is an example of a cross-cutting concern. Right? Another example is handling persistence. So you have a database and a component talks to the database, and the only thing is that it looks fine, but the only thing is that there are 10 other components which also do the same thing. And now you suddenly have code duplication across your classes. Like Anand was explaining about it, right? You have to look at the software that you have, very similar software that you have in your organization, so that you can reuse stuff. Right? When you don't do that, the components get duplicated. Now it's more than code duplication. It becomes your component duplication. It's a much bigger level of duplication, right? Sometimes code duplication, see if it is 1% of duplication, it may look like code smell. If it looks 10% of duplication, looks like the same problem. But if you have 60% of code duplication, perhaps an architectural problem, right? By architecture, by your design decision, you have so much duplication. Why is it happening, right? So this is something that we need to see. Now, the solutions may look very simple, but implementing it is very difficult. That is why I have a case study, a much more detailed case study.
Absolutely, it's one of the classic examples.
The classic example, as you said, refactoring in Windows from Windows Vista to Windows 7. So Windows Vista was a big success? No. So they had to do something, right? So you are an OS team, in Windows OS team, and you have to deal with this. So what do you do there? So here, they had to refactor the OS to improve what? Performance? No. To improve scalability? No. To get rid of layering problems, to get rid of dependencies problems. Why? You have a huge code base evolved over a period of 20 years. And you have all kinds of crazy dependencies, right? So they had a multi-year effort just to refactor the Windows operating system code. This is what they did, right? So if you look at the smells, and the refactoring looks very simple. For example, you are removing some of the dependencies, or move the dependencies, to simplify the dependencies. Or in layering system, you may want to get rid of the illegal calls, the incorrect calls, like layering violations. The only thing is, you have thousands and thousands of them. Right? So it becomes a multi-year effort, a team effort to actually make the refactoring happen. So if you look at the process aspect of it, what did they do? Right? They had a plan for refactoring. So they did a very detailed analysis of existing dependency structure. Right? So as you can see, this is much, much different than code refactoring. Do you agree? Right? And they had a team, and it was drilled down from the top. Right? So the architects actually, planned this effort, and they had a designated team for refactoring, one single team for refactoring, lots of people, only for refactoring, and they had used lots of custom refactoring tools, mainly for finding dependencies. Max is a tool, internal tool in Microsoft, and they had used processes like quality gate check to ensure that things are stable. So we are not doing something play refactoring here. We are talking about real operating systems, what we are using, right? So refactoring here would mean lots of considerations like this, right? So one of the practical situations, what I have also seen in architecture refactoring, is how do I deal with my regular changes versus the refactoring changes, A very simple illustration. For example, this is Windows Vista, this is Windows 7, these are the main changes. This is the main line, main trunk, and you have the non-refactoring changes, like for example support for media and other things, and you had improvement for performance, and you had a refactoring and a refactored dev. Now see, in a massive code base like this, where hundreds of developers are working, how will you deal with these changes? You have to merge them together and get a working software in place, right? So it's a massive challenge. It's a massive challenge. So the architecture refactoring is not a play stuff. It's not quite involved thing. And the smells what you're talking about may be very simple, like this, layering violation. But the thing is, what you are refactoring, the extent of refactoring, and the criticality of the refactoring is what makes it very difficult. Okay, so all is not well with architecture refactoring. There's so many challenges. When I was working with architecture refactoring topic, that I figured it out. So one of the things is actually one of the biggest fears what we have is actually fear of breaking the working code, right? And then we have other problems like not able to get buy-in for refactoring. For example, one of the projects I was involved with, they had used 10 different logging frameworks. Approaches. Can you really believe that? But have you seen that? Yes, right? So you have log4j, util.logging, custom log library, system.out.printlns. Now the team architect made a proposal to the management saying that, see, this is becoming crazy. I'm not able to debug. The team members are struggling to reproduce the problems. Right? How do you reproduce the problems? Through logging, and make fixes. So because you have 10 different logging frameworks and you have 10 different log files and so on. But do you think the management will easily agree for such refactoring? They just sort down. What is ROI? When I can add more features, why should I worry about fixing logging frameworks here? Right? So getting buy-in from management for refactoring is a big challenge in architecture. There is no simple solutions here. Perhaps the concept of technical debt and the architecture debt can help here. So the fear of breaking working software. Code refactoring, unit tests. Architecture refactoring. Think about refactoring OS, Windows OS. Unit tests is more than enough?
Everything has to be.
No, you have to test everything. Like, you have to do reviews. You have to create new kinds of tools to ensure your code is proper, your design is proper, etc. Right? It's a very big challenge. Whatever you do, finally it breaks. I'll share one simple experience in my career. So when I just joined my team, my first job, actually I made a change to the build file. What did I do? Poor guy me, I changed the order of the object files, the compiled files in C program. CC 1.c 2.c. Let's say it was there, and I changed it to CC 2.c to 1.c. 2.c 1.c. Right? This is what the change I made. Earlier code was like this. Just to give an example, okay? 1.c and 2.c, and I changed it to 2.c and 1.c. It does not matter. The only problem is it was a million lines of code, and it breaks somewhere. One test case of 60,000 test cases or so, it failed. And I had to we had to read root cause and find it out. We were doing the change checks in the clear case to find out what code changes caused this problem. But it was not code change that caused the problem. It was a change in the build file that caused the problem. Right? So any simple change that you can make has the potential to break the software. That's a hard lesson I learned. Do you agree with that? Yeah. Right? So this is a big problem with architecture refactoring. Lack of tool support. Take the example of Windows OS itself. They had to find out, create a new tool, MaxX, just to do dependency analysis and so on. And they had to do this refactoring. So lack of tool support what it means is lack of tools for quantifying the architecture debt, right? And the lack of tools for automated refactoring, automatic finding of smells, etc. They don't exist now. So this is a very new topic, right? Merge problems is a very big problem. So for example, let us say I have a main trunk and I'm making changes through refactoring. By refactoring, typically you have lots of changes in architecture refactoring. So how do you merge them together to the main line? It's always a big challenge. So these are some of the big challenges with architecture refactoring. So to quickly summarize what we actually gathered from this session, So architecture refactoring plays a key role as an enabler for business success. Do you agree? Right? So all this what we're talking about. Like for example, reduce the number of database instances. For example, right? It actually helps in reducing the cost, which actually helps business, right? And architecture smells can be viewed as violation of design decisions, principal design decisions, right? And viewing architecture as principal design decisions and smells as violation of that is a very, very powerful way, right? So just I quoted from my manager who said that one of the best ways to learn about architecture is actually to observe the software when it fails. In fact, smells is one way of failure, not a crash in fact, but it's not working, right?
It's telling you it's going to fail.
Yeah, it's telling us it's going to fail. So it's a very good way to actually learn about software architecture. Don't you agree with that? In 1 hour session, didn't you get at least one insight about software architecture which you didn't know before? Sure, right? So I would say that's a big takeaway, right? So with that, I come to the end of this session. So thanks a lot for your passionately listening to this session. Summary is architecture refactoring is an enabler for business success. Thank you.